Hey everybody, it's Julie, and in this video I'm going to talk about how we can write functions in C++ with reference variables. First I'm going to talk about how we write functions using pass-by value. Then I'll describe reference variables and how we can write functions using pass-by reference. So usually when we write a function, we pass by value, and that's the default. That means when I call the function's going to get a copy of the values that are in my program. Any change that's made to the parameters in the program only affects the copy. And here's an example showing what I mean. In my main function, I have a string name with Batman in it. Then I'm going to call a function, and when the function's finished, I'll display the value of the string name. Up in the function, I passed that string to the function, but I just used the standard pass-by value. And a copy of Batman was put in a new variable hero. These are two separate variables in two separate locations in memory. And even though the print name function is going to modify the string hero, the original value, the original variable is not changed. So the function print name will print Batman, superhero, but back in main, the name hasn't been modified, and so when main prints the value, it'll only print Batman. Now sometimes we'll use references because we want an alias to another variable. So we'll have a different name from the original name, but we're still referencing the same memory location. This is similar to using pointers in C, but it's much easier to use than pointers in C. And when we want to define a reference variable, we indicate that it's a reference variable with the ampersand. So I can create a double named amount and initialize it to $5.99. Then I can create a second variable named price, but this double is not a whole nother variable. This is a reference to the first variable. And if I print the value of the second variable, I'll end up printing the value of amount, $5.99. So how does this affect functions? Well, I can choose to pass references to my function instead of passing copies of the original values. And this is called pass-by reference. So when I use pass-by reference, we're not going to make a copy. And instead, we're going to give the function access to the original variable, and the function can modify it. So how do we set this up? In the function header, where we list our parameters with their data types, we'll add an ampersand between the data type and the name, and that's the only change we have to make. We don't have to change anything in the function call. So here is that same program, except now in the print name function, the only change I made was to add the ampersand after string. So now when I call print name, I'm not going to copy the value that's in name to hero. Hero's just going to be a reference to the same memory location. And when I modify hero by adding superhero, I'm also modifying, or actually modifying, the original one that's inside of main. So I am changing the value of name. And then when this program runs, inside print name, again, it will print the same thing it printed before, Batman, superhero, But this time when main prints the value in name, it's printing the changed value, Batman, superhero. So the only difference in this program that I made was adding the ampersand, and that now changes the parameter to be a reference instead of a copy. So why do we want to use reference variables? We may have a function where we want to modify multiple variables. And one thing about the way functions are defined in C++, they can only return a single value, and if we want to modify multiple variables, we can't do it with the return type. But we can use reference variables to allow the function to modify multiple parameters or multiple variables. And a situation in which we might want to do that is if we have user input, where we want the function to get the input from the user and we're asking them for more than one thing. So it could look something like this. I have a function named getDimensions, and it has two parameters. They're both doubles, and they're both references, length and width. When I ask the user for the length and width, and I get the values from the user, I'm actually populating the original variable that was in the function that called this function. Another situation where we might want to use reference variables is when we're working with large parameters. If we have a large variable, we may not want to make copies when we make function calls because that's just having the program do a lot of extra work and it's inefficient. So sometimes we may use a reference variable just so that we're not copying the data multiple times. Now, we may not want that function to modify the variable, and so if we only want to give it a reference so we can avoid copying, but we really don't want to allow that function to make any changes, then we can put const with the parameter, and that will prevent the function from modifying the value. So if I were to change that same function, print name, by adding const in front of the parameter data type, what I am saying is you're going to get a reference to the original value, but you're not allowed to change it. And in the body of this function, when I try to modify it, that's not going to compile. That's not going to be allowed because the const says name cannot be modified. So, what have we talked about here? We first looked at pass by value, and that's the default way functions work. When we use pass by value, the function's going to get a copy of the original value. Or we can use pass by reference. The function gets a reference to the original variable, and it can make modifications to it. But we can prevent modifications by using const before the data type in the parameter list.